Hey, my name is Patrick, and today we're going to talk about the basics of steam heat, especially steam heat as it relates to your residential housing. So right here we have a boiler. It's a simplified drawing of a boiler. What's boiler? Boiler is a container inside which you have a little bit of water, and as you warm up this water with whatever means you have, electric, oil, gas, that water, as we all know, turns into steam. That steam then raises up and, let's say, escapes into the atmosphere in a typical container that we use on a stovetop. However, inside the boiler, the whole thing is enclosed, so because of that, we can redirect the steam into certain places. So what can we do with the steam? Via the pipes, we send it down the main to this thing called main vent. Main vent, what it is basically, it's an opening in the pipe. Now, why is it necessary? It's because the steam and air doesn't mix. So because of that, they kind of like, those are two gases, and the one is pushing on the other. Now, at the same time, air, you cannot compress the air. You have to release the air through from the main pipes via something. And if you kept it as simply an opening, indeed, the steam would push the air all the way outside of the opening. But there would be a problem. Because it's just an opening, then the steam would just start escaping via this opening. And because of that, they introduced this thing called vent. So function of a vent in its basics is to allow the air to escape and close itself at the moment the steam hits it. It's the moment the steam hits the vent, so that the steam gets trapped inside here. Now, again, there's a bunch of different codes that I'm going to talk about in just a second. When the steam gets trapped in the main pipe, then the steam can, by definition, wants to go somewhere and starts going up the risers into the radiators. And the radiators, just like the main pipe, has a vent. So the radiator has air vent as well. And then, again, steam pushes the air out of the radiator through the air vent, and then when the steam hits the air vent closes, and then the radiator stays nice and warm and starts releasing heat into your room. Now, as the hot steam touches cold pipes, by definition, the steam condenses a little bit. So there's a transfer happening. So the steam warms up the pipes, at the same time loses some of its steamness, to use totally a colloquial term, and then you have this water condensate, and this water condensate has to somehow return back into the boiler. So as you notice in this specific diagram, this pipe right here is actually pitched in this direction. So that means all the condensate, by force of gravity, is going to start flowing this way, and then finally pass the main vent, goes down here, and starts flowing. Again, all of it's pitched properly towards the boiler via gravity, and then through this loop right here enters back into the boiler water, and it gets, by then it's still hot, and then it gets constantly reheated as long as there's a call for heat. So the same condensation takes place inside the radiator. So you have the hot steam touches the cold surfaces of the radiator. By that, condensation happens. All the condensate drops to the bottom of the radiator, and then radiator, again via the force of gravity, is flowing back into the pipes. If you notice, there's a little little block of something under the radiator. So radiator is not actually perfectly parallel to the floor of the space. It's actually pitched towards this opening, so that the condensate can easily flow out of it back into the main pipe and then back into the boiler. And that's the fundamental, very simplified basics of how the steam heat works inside a residential building.